we get from this, we get x1 is equal to how much? X1 is equal to -2. Y1 is equal to 2. X2 is equal to 2. Y2 is equal to 2. X3 is equivalent to 2. And Y3 is equivalent to 7. By using this value, we can find the distance between three sides. Okay. First, we find the distance between PQ. Then apply the distance formula, that is x2 minus x1 square. Yes, under root x2 minus x1 whole square plus in bracket y2 minus y1 square. Is it clear? Now put the value of x1, x2, y1, y2 from this side. x2 is equal to 2. x2 is equal to 2 minus x1 is equal to minus 2. Now put minus 2 in bracket. Okay. Square plus y2 is equal to 2 and y1 is also equal to. Clear? Now solve it. 2 as it is. This minus becomes plus. Square. Here 2 minus 2 0. 2 minus 2 0. Okay. Finally we get 2 plus 2, that is 4 square. Okay. Now square of 4 is equal to 16 and root of 16 is 4. Or you can also solve this square. You can also solve this. Root and square get cancelled. So 4. There are two methods to solve this type of questions. You can first find the square of 4, that is equal to 16, and root of 16 is equal to 4. Or you can directly say that square and root get cancelled, we get 4. Okay. Now finally we get distance between PQ is equal to 4. Okay. Here we find only one side, that is the distance of PQ. Then we find distance of QR. Applying formula, distance formula. In this case, we take Q and R. So, we write x3 minus x2 square plus, yes, y3 minus y2 square. Okay. Now, next step, put the value x3. How much? x3 is equal to 2. Yes. And x2 is equal to 2. 2 minus 2 square. Then plus y3 is equal to 7. y2 is equal to minus 2. Okay. Now 2 minus 2, 0. 7 minus 2. 7 minus 2 is equal to 5. Okay. Now apply same condition here. Shall I cancel square and root? Then we get directly 5. Okay. This is the distance between QR. Clear? Then next, third, that is we find the distance between P and R. P, R. We take coordinates of point P and coordinates of point R. Okay. Now we write x3 minus x1 square plus y3 minus y1 square. Okay. Now next step, put the value of x3, x1, y3, y1 from this. x3 is equal to 2. Yes, x3 is equal to 2. Yes. And x1 is equal to minus 2. Okay. Plus y3 is equal to 7. And y1 is equal to 2. Solve it. 2 as it is. This minus of minus becomes plus 2 square. 7 minus 2 is equal to 5 square. Okay. Now plus 5 plus 5 square. Okay, listen. In this case, you are not cancelling this 2 and 2. Okay. If the question is like that, whole square, then you will cancel root and square. But in this situation, it is different from this type. Okay. Now you find separately the square of 4, that is 60, and square of 5 is equal to 25. So you get distance of PR is equal to, yes, 25 plus 60, 41. It is under root 41. Is 41, under root 41 is a any perfect square root? No. So keep it as it is. Okay. Then here, now we check. Here we take distance of PQ square. We have to show that PQR are the vertices of right angle triangle. Then we check which of these three, out of these three, which of the two side square is equal to square of remaining third side. So first we take the distance of PQ square plus distance of QR square. We just check. If it is equal to third side, then we say that PQR are the vertices. Then the distance of PQ, that is equal to 4. 4 square plus distance of QR, that is equal to 5 square. Now 4 square is equal to 60. 5 square is equal to 25. Clear? Now we get, yes, how much? We get 41. That is distance here. If we squaring this PR square, if we square it, you will get 41. How you get 41? If I squaring this, then at that time square and root get cancelled. So square of distance of PR is equal to 41. So shall I write here? Distance of PR square. That means when we adding the square of distance of PQ and square of QR, we get distance of PR square. So finally we conclude that distance of PR square is equal to distance of PQ square plus distance of QR square. If these conditions satisfy, then we say that the points, hence we say that point P, Q and R are the vertices of right angle triangle. Okay, hence listen, I have again explained this question. Okay. First you have to write down the coordinates of P, Q, R. Okay. Now first find the distance between PQ, distance of PQ, then use the formula, distance formula. We get the distance of PQ is equal to how much? 4. Then we take another side, that is QR, and find the distance between QR. We get 5. Then we take 2 points, that is PR and R, and finding the distance between them, that is distance of PR is equal to, yes, equal to under root 41. Then we check which of the square of the two sides is equal to the square of third side. After checking, we get distance of PQ plus distance of QR is equal to distance square is equal to distance of PR square. Hence, we conclude that point PQR are the vertices of right angle. Clear? So in this way, you can solve this type of questions. Clear? Or if you want to draw a diagram for this, you can draw at which point. Listen, this one is the hypotenuse PR. Hypotenuse square is equal to one side square. This one is one side and this one is another side. So from this we conclude the hypotenuse square. Hypotenuse, that is PR square, is equal to one side square plus other side square. Okay. Okay. So now I rub this question. Remaining questions from this practice set are based on this such type of questions. Okay. So if you know how to solve this type of question, then remaining question is easy for you.
Sujata ma'am?
Yes, ma'am.
You can wind up. Okay?
Okay, ma'am. Okay.
Okay.